Hello friends, in this video we are going to discuss about another concept associated with matrix. So the topic here is equality of matrices. Okay, so two matrices, okay, they are considered to be equal, okay, are said to be equal if they satisfy two important conditions. Okay, two conditions. The first condition is that they should be of the same order. Okay, they should have same order. It means that the number of rows and number of columns of both the matrices should be equal. Okay, equal number of rows and columns for both the matrix. And the second condition is that the corresponding elements, okay, the corresponding elements that are present in both the matrices, they should be also equal to each other. Okay, corresponding elements should be equal. Okay, so for the equality of two matrices, both the matrices should have the same order. It means the row and columns of the first matrix should be equal to the number of rows and number of columns of the second matrix. The second condition is that the respective elements at the respective position should be equal in both the matrices. Okay, now let us say that we have two matrices A and B. Okay, matrix A and matrix B. Let the matrix A be written in this way: 1 1, A 1 2, A 1 3, A 2 1, A 2 2, A 2 3, A 3 1, A 3 2, A 3 3. Okay, this is matrix A. So here we see that is a square matrix of order 3, 3 rows and 3 columns. Now for matrix B to be equal to matrix A, it has to satisfy the two basic conditions of equality of matrices. So it must also be a square matrix of order 3, that is 3 rows and 3 columns. Let us just write down the matrix B. It be B11, B12, B13, B21, B22, B subscript 23. This is B31, B32 and B33. This is matrix B. So this is also a 3 cross 3 matrix, square matrix of order 3. So for the order condition is satisfied. Okay, the order condition is satisfied. This is also a 3 cross 3 matrix, that is 3 rows and 3 columns, and here also it has 3 rows and 3 columns. The first condition is satisfied. But for equality, the second condition is that the corresponding elements of both the matrices should be equal. That is, A11 should be equal to B11, A12 should be equal to B12, A13 should be equal to B13, and so on. the corresponding elements, the respective elements which are present at the same position. A11 is present at the intersection of the first row and the first column. It should be equal to B11, which is also present at the intersection of the first row and the first column. Similarly, A12, which is present at the intersection of the first row and second column in matrix A, should be equal to B12, which is also present at the intersection of the first row and the second column. So this is the second condition for the equality of matrices, that is, the respective elements at the respective positions, means the intersection of the rows and columns, they should be equal to each other. That is, here A11 should be equal to B11, A12 should be equal to B12, A13 should be equal to B13, and so on. So in general we can write this as Aij, okay, Aij should be equal to Bij, okay. This is also n cross n and this is also n cross n. Both their orders should be equal and the respective elements should be also equal, okay. So this is the two basic conditions for the equality of a matrix, okay. First, the order of both the matrices should be equal, that is the number of rows and number of columns, and second, the respective elements at the respective positions, they should be equal to each other, okay.